Hello everybody, this is Carm Killed the Cat, and welcome to your 19th C++ tutorial. In this tutorial, we'll be going over error handling in our programs. So let's get started. So before we get into how to handle errors, let's start with an example. So say we want to create a program that took two numbers in as input and then divided the first number by the second number and output that value. So let's just quickly create the program. Say double x and y. And oops, not capital D. Sin x and sin y, and then we just output those two numbers divided by each other. So x over y and end line. So let's run this just to be absolutely sure it works. So we'll just say 10 over 2, or no, we don't. Say 10 and 2, and that's 5. So it works fine, obviously, and it just takes the first number and divides it by the second number. But what if the user said something like 45 and 0? So you can probably guess what would happen. It freaks out. 1 point number sign inf. And mathematically the right answer would be undefined, but I'm not exactly sure what this means, but it means a divide by 0 exception happened. So we obviously don't want the user to see that, because if you don't know how to program, then that would look completely foreign to you. Even I don't know exactly what it means. So what we are going to try to do in this tutorial is create something that makes a more clean error when you try to divide by 0, instead of just saying 1 point number sign inf, because that's in programming terms, that's very unclean. We want an error that the user can read and the user can know how to solve, or just know what happened. So to handle this error in a clean way, we're going to use what's called try-throw-catch blocks. And what these are is it's something that allows you to run code in kind of a safe mode, and if anything goes wrong, you can do what's called throwing an error, which is kind of like returning. It's like, say the try block is, here I'll show you, so we'll say try, and then we'll make that surround our output statement. So we're saying that we're trying to run this code, and if a problem occurs, we can throw an error, and that will go to this catch block, and the catch block takes a parameter, and we'll call it error code, and then it has a body like a function. So to determine whether there was a divide by 0 error, we can just say if y equals, oh, I need parentheses, y equals 0, then we'll say throw, we throw the error, throw, and we'll just say 1. So we're throwing error code 1. And in our catch block, we'll say if error code is equal to 1, again I need parentheses, then we'll just output, we can output cannot divide by 0, and end line. So, oh, we need standard. So now what we're saying here is we're creating our variables, getting the input for them, and then we're running all the code in here in a kind of safe mode. So we're saying that if y equals 0, so the number that the first number is being divided by is 0, then we throw 1, and that's our error code. It's just error code 1. And if there are more errors, we could have error code 2, 3, 4, and so on. And then if y is not equal to 1, then we can just run our output statement normally. We don't even need it to be in the try block. That's just confusing. So it can be after this try block. So now all the try block says is if y is 0, throw 1. And then the catch block catches the error that was thrown by the try block, and then you can use the code in here. We need to add another less than sign. And in the body of the catch block, you can determine how to handle the error based on the input you get from the try block. So now if we run this, it will still run normally if we just say something like 10 and 2. Nothing changes, it just says 5. But if we say 10 and, don't need a comma, 10 and 0, then we get cannot divide by 0 and number sign inf. And actually, we probably should have the output statement in here, because I believe the try block gets terminated if an error is thrown. So now if we say 10 and 0, we just get cannot divide by 0. So this is a much cleaner error than if we just got the 1 point number sign inf. Any normal user wouldn't know what that means and would probably just get confused, especially if it wasn't such an obvious error like a division by 0. And divide by 0 errors don't always have to be obvious, because in this case we're just taking input, so the user would know if they divided by 0. But in some cases you could just have variables that aren't controlled by user input, and one of them just happens to be 0, and then you try to divide by that number, and you get the divide by 0 exception. And that would completely cause the program to fall apart in most cases. So you need these error blocks, the try throw catch blocks. So what you're probably wondering right now, I definitely was when I first learned about this, is why you can't just completely omit the try catch block and say if y equals 0, just output cannot divide by 0, else output x divided by y. And while this would work, that would work just as well as the try catch block in this situation, there are more advanced error situations where a try catch block would make much cleaner and much easier to write code, because you might need like a you might need if error equals 1, else if error equals 2, else if error equals 3, and so on if you have a bunch of different possibilities for the error. And another thing is what we're going to get into in the next few tutorials, the STL libraries, which are kind of like more advanced arrays. I won't talk about them too much now, we'll be getting into those in the next few tutorials. Those use those throw errors quite a lot if you do something wrong with them. So there's really no way to manage the error if you don't use try-catch blocks, but if you do use try-catch blocks, then the errors are quite easy to manage and shouldn't give you too much trouble. So although they don't seem too useful now, these are very important to C++ programming, and you really should know them. Don't just ignore them because you think you can do the exact same thing with if statements. They make your code clearer, easier to read, and a lot simpler. So learn this, play around with it a little, and that's all for this tutorial. In the next tutorial, like I just said, we'll be going over the STL libraries. The first one we'll be going over is vectors, and that's not the same as a mathematical vector. You'll see in the next tutorial. So see you then.